Hi, my name is Jessica Booker, and this is another video synopsis. I will be discussing Chapter 6 from Wardlaw's contemporary nutrition book, the 9th edition. Before the chapter begins, it states that consuming enough protein is vital for maintaining health. Proteins form important structures in the body, make up a key part of the blood, help regulate many body functions, and can fuel body cells. Our daily protein intake comes mostly from animal sources, such as meat, poultry, fish, eggs, milk, and cheese. In the beginning of this chapter, in Section 1, it introduces proteins. Thousands of substances in the body are made of proteins. Aside from water, proteins form the major part of the lean body tissue, totaling about 17% of body weight. Proteins are crucial to the regulation and maintenance of the body. Body functions such as blood clotting, fluid balance, hormone and enzyme production, visual processes, transport of many substances in the bloodstream, and cell repair require specific proteins. The body makes proteins in many configurations and sizes so that they can serve these greatly varied functions. Proteins can also be broken down to supply energy for the body, on average 4 kilocalories per gram. It also touches base with amino acids. In Section 2, it talks about amino acids bonding together. Amino acids are linked together by chemical bonds, technically called peptide bonds, to form proteins. The body can synthesize many different proteins by linking together the 20 common types of amino acids with peptide bonds. Protein synthesis, protein organization, and denaturation of proteins are all discussed in Section 2 as well. We just did an experiment of the denaturation of proteins. We were able to distinctly observe the proteins and take note of their purposes. In Section 3, it talks about protein in foods. Some of the typical foods that we eat, about 70% of the proteins come from animal sources. The most nutrient-dense source of protein is water-packed tuna, which has 87% of calories as proteins. The top 5 contributions of protein to the North American diet are beef, poultry, milk, white bread, and cheese. In North America, meat and poultry consumption amounts to about 150 pounds per person per year. Worldwide, 35% of the protein comes from animal sources. In Africa and East Asia, only about 20% of the protein eaten comes from animal sources. Another topic in this section is the protein quality of foods. Animal and plant proteins can differ greatly in their proportions of essential and non-essential amino acids. Animal proteins can contain ample amounts of all 9 essential amino acids. Human tissue composition resembles animal tissue more than it does plant tissue. The similarities enable us to use proteins to form any single animal source more efficiently to support human growth and maintenance than we do those from any single plant source. For this reason, animal proteins, except gelatin, are considered high-quality proteins, which contain the 9 essential amino acids we need in sufficient amounts. Individual plants of proteins, except for soybeans, are considered low-quality proteins because their amino acid patterns can be different from ours. Meaning, a single plant protein source, such as corn alone, cannot easily support body growth and maintenance. Section 3 also talks about a closer look at plant sources of proteins. Section 4 talks about protein digestion and absorption. In digestion, the enzymatic digestion of protein begins in the stomach. Proteins are first denaturated by stomach acid. Pepsin, a major stomach enzyme for digesting proteins, then goes to work on the unraveled polypeptide chains. Gastrin also strongly stimulates the stomach to produce acid. The partially digested proteins move from the stomach into the small intestine along with the rest of the nutrients and other substances in a meal. Once the small intestine, the partially digested proteins trigger the release of the hormone cholecystokinin, known as CCK, form the walls of the small intestine. CCK in turn travels through the bloodstream to the pancreas, where it causes the pancreas to release protein-splitting enzymes such as trypsin. Those enzymes Those digestive enzymes further divide the chains of amino acids into segments of 2 to 3 amino acids and some individual amino acids. Eventually, the mixture is digested into amino acids using other enzymes to form the lining of the small intestine and enzymes present in the absorptive cells themselves. In absorption, short chains of amino acids in any individual amino acid in the small intestine are taken up by the active transport into the absorptive cells lining the small intestine. Any remaining peptide bonds are broken down to yield individual amino acids inside the intestinal cells. With excess protein intake, amino acids are converted to fat as a last resort. Section 5 talks about putting proteins to work in the body. It goes over producing vital body structures, maintaining fluid balance, contributing to acid-base balance, forming hormones and enzymes, contributing to immune function, forming glucose, providing energy, and contributing to satiety. Section 6 talks about protein needs, while Section 7 talks about whether or not eating a high-protein diet can harm you. Section 8 talks about protein-calorie malnutrition. Sorry if I pronounced any words wrong, but that's all I have for Chapter 6. Thank you for watching.